in this problem, you have two charges. So one charge is right here at this point. You have one charge plus 4 microcoulomb, and you have another charge minus 4 microcoulomb. Due to these two charges, we have to find out the potential difference at points A and at point B. So VA minus VB. So in order to find out the potential difference, we need to understand what is the potential at a point due to a charge. The potential is simply given by K Q over R, and it is a scalar quantity, and this is due to a point charge. As we have the charges at point A, we know this distance, and due to this charge, we do not know this distance, so we have to find out this distance here. So we have to find this distance first. Oops. And we also have to find out this distance as well. Alright, so this is 0.3, this is 0.4, so this distance will be simply equal to 0.3 squared plus 0.4 squared, which would be equal to 0.5 meter. And this distance will also be 0.3 and 0.4, so this will also be again be 0.5 meter. All the distances are now given. So let's calculate first the electric field at point. We call this charge Q1 and we call this charge, let's call it Q2. I'm calling this distance R1. So this one will be R1 as well. And this I call R2 and I'm calling this as R3. R3. So this one will be R3 as well. Okay, or I can call R1. Let me write down the different notation. R1, R2, R3. Let me call R4, and this is called R5. This is R1, this is R2, this is R3, R4, and this is R5. Okay. Now, let's calculate the potential at point A. I'm calling this as a BA. The potential at point A is due to this charge and due to this charge. Due to this charge here. So this one will be KQ1 and this distance is R1 plus KQ2 and the distance from this point to this point. Now this one is R4. Okay. From this point to this distance to this point A, the distance is R1. From this charge to point A, the distance is R4. So now let's plug in all the values. K value is 9 times 10 to the 9, so I'm just taking this one out. Q1, the charge is 4 microcoulomb, so this one would be 4 times 10 to the negative 6. The R1, the distance is 0.3 meter, plus Q2 is minus 4 microcoulomb. This is minus 4 times 10 to the negative 6. And R4 is 0.5 meter. So when you do this math, the number you'll get it 48,000 volt. So That's the potential at point A due to charges A, Q1 and Q2. The same way, we're going to calculate the potential at point B. We call VB. How do we write now? K at this point, Q1, and the distance from Q1 to this point is R5. I'm just writing R5 plus K Q2. From this point to point B, the distance is R3. R3. Plug in all the values now. So K is 9 times 10 to the 9 K value, and Q1 is 4 microcoulomb, 4 times 10 to the negative 6, and distance R5 is 0.5 meter, plus Q2 is minus 4 microcoulomb, and R3 is 0.3 meter. If you do this math, you'll get the number which is equal to minus 48,000 volt. This is for 48,000 volt. So the potential difference, is given VA minus VB. This will be 48,000 minus 48,000. So this would be 96,000 volt. 96,000 volt. We can simply write down as a 96 kilovolt. So that's the answer. Okay.